I invite Ms. Laurencia Sutianto. Please, you have 10 minutes for a presentation.
Okay, thank you. Is my voice clear enough?
Yes, we can hear your voice.
I would like to start the sharing screen.
Okay, please.
Can you see my slide?
Yes, we can see your slide and your presentation.
Okay, thank you. Good afternoon, judges, professors, ladies and gentlemen. I would like to thank first my supervisor, Ms. Lina Gozali, ST, MM, PhD, IPM, and Professor Dr. IR Franz Yusuf Daiwin, MSc. And I would like to thank the IEOM Society for giving me this opportunity to present the modification of food dehydrator for tea blend products using reverse engineering and VDI 2221 methods. Let me introduce myself. My name is Laurencia Sutianto. I'm a student of 8th semester bachelor program of Industrial Engineering Department from Universitas Tarumanegara. This is my presentation outline. Consists introduction, literature review, research methodology, data collection, result and discussion, conclusion, references, and biography. The introduction, the tea blend. The tea blend is a blend of tea leaves with a tisane made from flowers, seed, roots, stem, and bark. In addition to choosing quality teas as the main element in the tea blend, tisane such as dried fruit is also a very important element to produce a balanced taste and increase the value and the benefits of the tea blend. In the tea blend, the fruit goes through a process of dehydration. However, food dehydrator on the market do not just focus on drying fruits. Therefore, there will be a task for the food dehydrator performance with fruit experimental materials to produce the optimal treatment method. After that, the food dehydrator will be modified to produce a comparison of tool performance using reverse engineering and VDI 2221 methods. In addition, is it necessary to conduct market research by distributing questionnaires about customer habits in consuming tea and consumer interest in the tea blend products? The questionnaire result data will be processed using the conjoint analysis method, and this research aims to report a summary of consumer reference based on the market research and find a modification model of food dehydrator to find adjustment of the machine performance to produce a dry fruits with optimal drying. The literature review. The blending tea is an art form. Is it important? It is important to gain certain tea blends and seize the market. Tea can be mixed with different types of tea, herbs, flowers, and fruit that has been through the drying process. However, fruits and vegetables contain high water content, ranging from 80 until 90%. This condition must be considered in the food dehydration, which is focused on decreased levels contain water. Using a food dehydrator machine and with the reverse engineering method, knowing the principle, the performance, object, or system can be done by analyzing its structure, function, and operation. Then the modification will be done by using VDI 2221, a systematic approach to design for engineering system and engineering products. This is the research methodology. We start from the market research and the main goal in this section is obtain respondent data and attribute level that respondents consider in buying products. Then we go to determination of attributes and attribute level, which was attribute taken are included in the 80% cumulative percentages obtained from the processing of the questionnaire that will be used as the reference in determining the attribute level for further analysis in the second questionnaire. Then we're going to determination of number of profile card. From the result, the combination profile result will be listed into the second questionnaire with an assessment using a Likert rating scale 1 until 5. Then we're going to validity and reliability using the Pearson product moment with R value distribution of 0.195 with the sample of 100 respondents and a level of significance of 0.5. Then we're going to conjoint analysis, and the remaining valid and reliable profile card will be analyzed using conjoint analysis. Then we're going to food dehydrator performance test, whereas there's 2 experiments. The first experiment by preparing 9 slices of strawberries with a thickness of 0.5, 0.7, and 0.9 centimeter using the different temperatures by the manual book is 50, 55, and 60 degrees Celsius. Then the experimental time used was 180 minutes by measuring the water content every 30 minutes by this formula below. The second experiment will be carried out to find the optimal temperature and slice thickness for drying strawberries with the same treatment as the first experiment. Experiment will carried out 3 times for the valid data. Then we're going to design experiments. By doing this, we're using two-way ANOVA with alpha use is 0.05. To observe variables are temperature and thickness, and the variable response, the water content released in %. And we're going to the hypothesis where the hypothesis 0, there is no interaction effect between temperature and slice thickness on the water content release. And the hypothesis 1, there is the interaction effect between temperature and slice thickness on the water content release. Then we're going to reverse engineering method, where existing products are removed and measured even if they need to be tested. In this process, the dimension of each part of the product has been disassembled. The next process is to improve the design and then assemble it again according to the new design. Finally, a performance test is carried out, and if it meets the specification, the product can be remade and ready to be marketed or used. These are the components, the description, and dimension. And this is the design engineering methods or VDI 2221. The design of VDI 221 is a method for solving problems and optimizing the use of materials. After determining the initial specification, a solution principle needs to be made for the selection. And the next step is to make the possible combination to form the most supportive system. One way of selecting variants can be done by using a selection diagram, and these are the section by section by determining the initial specification from parameters to demand or wish, then making possible combination, and then choosing the best combination. In conclusion, considering the production cost side and according to the desired function for modifying the food dehydrator machine, variant 1 is selected, which will continue to the next process. Then we're going to data collection. All data will be collected by distributing questionnaire about consumer behavior in consuming tea and consumer insights in tea blend for the market research. Then the result will be analyzed using conjoint analysis method and formed into a product combination based on consumer preferences. For the machine performance, all data will be collected by doing 2 experiments. The first experiment will be find how much time is needed in the fruit drying, and the second experiment will be finding the optimum treatment for fruit drying. This is the result and discussion, the market research. This is the questionnaire result. Based on the initial questionnaire result, there are 265 respondents were obtained. And after the elimination question, the total of respondents that has been filtered was 255 respondents. With this amount, the result contains the attributes that the respondent would choose as a preference for tea blend products. The 6 selected attributes above 80%, which I have highlighted on the table, will be described for each attribute levels for further analysis in the second questionnaire. In the table for each attribute level, the attribute level is the attribute level with a minimum percentages of 80% for each attribute of the respondent answer. And the profile card will be determined based on the attributes and the attribute level above using fractional factorial design. And this is the profile card. And from the fractional factorial design, there are 16 combination profiles that are obtained. The 16 profile cards will be entered into a follow-up questionnaire with assessment using a Likert rating scale 1 until 5 with a sample 100 respondents. And from the validity test, it was found that 4 items had R value below 0.195, which is the question 1, question 5, question 8, and question 9. Reliability use the crunchback alpha coefficient with the condition that the crunchback alpha value must be more than 0.6, and the calculation results shows that all data are valid. So we're going to conjoint analysis. After testing the validity and reliability, the remaining 12 profile cards will be analyzed using conjoint analysis with the result below. Based on the part word utility value, the combination of level is obtained, which are the tea blend with a sweet taste, medium aroma, price of IDR 25,000 rupiah to 35,000 rupiah, or in dollar, it's 1.75 US dollar until 2.45 US dollar. The type of tea leaf used is a black tea with variants of dry fruits, and the number of content is 50 until 100 grams. This is the result of food dehydrator machine performance test. The experiment was carried out 2 times. The first experiment to determine the working time, and the second experiment with a predetermined time. In the first experiment, the result will be focused on finding the average time it takes for the machine to get moisture content of below 10%. And this is the result. This is the picture of the strawberries that I have dried. And the calculation data found the average time to produce the water content to below 10% for each slice with different temperature treatment was 120 minutes. The result obtained will be fixed variable in the second experiment. This is the result of the second experiment, and this result will be continued to the next step, which was the design of experiment calculation using ANOVA or analysis of variance. Then we're going to the design of
1 minute left.
Thank you. And we're going to design the experiment where this is the conclusion obtained is p-value, is less than 0.05, then the hypothesis 0 is rejected, meaning there is an interaction effect between temperature and thickness of the slice of the water content released. And the experimental result also produced a grouping table, which using the Tukey's method, where the result of the combination group showed that using a temperature of 60 degrees Celsius and a slice thickness of 0.7 centimeter produced the best result for the experiment with a time of 120 minutes. And with this result, the data of water content released on this experiment will be the standard for comparison with the experiment after modification, which was 91.3%. And this is the result of design modification, which are I changed the propeller of the heating units with this component. They are the table, the components, the figures, description, and dimension. And this is the food dehydrator modification result analysis with the same treatment as before. Based on the result, it was proved that the water content released on the experiment after modification increased to 93.8% with the same experiment time, which was 120 minutes. And this is the product prototype. And after going through market research, data processing using conjoint analysis, and modifying the food dehydrator machine to suit the needs for the food drying, prototyping of semi-finished product or dried fruits for the business model, and the finished product or end user product is carried out. This is the blending tip process, and this is the product prototype. I will play the product prototype. This is the product prototype.
Okay, Ms. Laurencia, your time is up. I would like to ask from the audience.
Thank you
If you
for
have
your
any
attention.
question. Okay. Any question from the audience? Okay, because we have no question from the audience. I have one question, Ms. Laurencia.
Yeah.
You are improving the products, the
Yes.
dehydrator.
Yes.
Is that correct?
Yes, it's correct.
I would like to ask about what are the drawbacks of the old system or the old products, and then you improve or you upgrade this old product or old dehydrator. What are the drawbacks of this old or the old system?
Thank you for the question. Now I'm going to answer that. The previous propeller in the heating units, the machine, it only blew the winds in the middle of the machine. So I was thinking, how can I make the result to the maximum by changing the propeller itself, not changing the whole units, but only changing the propeller itself. So I was making benchmarking, I was making prototyping, and I found this kind of propeller that I have shown before. It was the perfect propeller to change change the propeller before. So the new propeller, it worked perfectly with evenly wind blowing to every section of the body, like that.
Did you change the head elements
No,
from the
I
product?
didn't.
Or not? You use the same heater element from this product.
Yes.
Okay. Okay. Thank you, Ms. Laurencia. An
Thank you so
interesting
much.
research and very useful products. Okay, we continue to the team with ID 153 with research title Supply Chain Risk Assessment of Hazardous Chemical Products in a University Laboratory and in a University Laboratory. I would like to invite